Hi everyone, welcome back. This is me, Ankita Menon, coming up with the fourth video from Surface Chemistry. The topic of discussion today is Freundlich adsorption isotherm. All right, so by now we know what an isotherm is. Isotherms are those graphical representations which are plotted at constant temperatures. At constant temperatures. And today we are going to discuss about one among the different types of adsorption isotherms that we have to learn. And its name is Freundlich adsorption isotherm. It's very easy. So let's start with the equation. Okay. Now, according to the Freundlich adsorption isotherm, what it says is theta. Now, theta is the extent of adsorption. Extent of adsorption is equal to x by m. This is the equation put forth under Freundlich adsorption isotherm. Okay, what is x? X is the amount of adsorbate. Adsorbate means the moieties which get adsorbed on the surface. And m is the mass or amount of adsorbent. Adsorbent is the surface on which adsorption happens. So very easy, theta is equal to x by m is one of the form of equation 1, one of the form of Freundlich adsorption isotherm. Apart from that, there is another equation, which is theta is directly proportional to p to the power 1 by n. So by now, we already know that the extent of adsorption increases with the pressure. And here P, let's say, is the partial pressure of the gas. Pressure of the gas. So if you have a solid surface, and on the solid surface, if you have certain gaseous molecules being adsorbed, okay, so this is the adsorbate. This is the adsorbent, and P is the partial pressure of the adsorbate. Now, to remove this proportionality sign, we multiply it with the proportionality constant K, P to the power 1 by N, where K and N are Freundlich constants. Are Freundlich constants. Freundlich constants. Okay, so this is equation 2. So these are the two equations that govern Freundlich adsorption isotherm. Very easy. The extent of adsorption is equal to the amount of the adsorbate divided by the amount of the adsorbent, or the extent of adsorption is equal to some constant into P to the power 1 by n. Now please pay attention. In certain books, you can see the equation written as theta is equal to Kp to the power n. Instead of 1 by n, you can see that this is written as n. So both the forms are right. What you have to understand is whatever the power is, whether it is n or whether it is 1 by n, whatever it is, the power will be always less than 1 and above 0. Okay? So if I have to write it over here, theta is equal to Kp to the power, whatever power. That power can either be n or it can be 1 by n. This power is always less than 1, usually, okay? So different textbooks, they use different notations, and it's fine even if you see n or even if you see 1 by n. So please don't get confused looking at that. Okay, now let's come into the graphical representations. Now we know the two forms, x by m and Kp to the power 1 by n. Now, depending on the conditions, we can draw different plots. So let's draw. So let's say that you take the equation theta is equal to Kp to the power 1 by n, and let's put the value of 1 by n as 1. So it becomes theta is equal to kp to the power 1. Now we know under an adsorption isotherm, we plot the extent of adsorption versus pressure at constant temperature. And here theta is directly proportional to P. It is showing a linear relationship. It is showing a linear relationship and hence it will be a straight line. It will be a straight line, correct? It will be a straight line. That's it. So this is how the plot will look if the value of the power is equal to 1. So this is case 1. Case 1. Okay. Clear? All right. Now the second case, case 2, is again, we know that theta is equal to kp to the power 1 by n. The power will not ideally be greater than 1, but let us assume that if 1 by n is equal to 2. Now see, ideally this does not happen under the real situations, but let's assume that the value of 1 by n is equal to 2 because for exams, you also get arbitrary questions. You get arbitrary scenarios, so you should know how to, plot whatever values are given. So if 1 by n is equal to 2, or we can write as theta is equal to kp to the power 2. Let's say this is the case. So if this is the case, if we have to plot, this is theta versus p, and here the form that you have is y is equal to ax square. And this takes the shape of a parabola, which is something like this. This is how it will look. Right? This is how it will look. So this is case 2, corresponding to a value of 1 by n being 2. Now, last case. Case 3 is where theta is equal to kp to the 1 by n is the formula of the Freundlich adsorption isotherm. Now, by now, this might be registered in your mind. Now, let's say that the value of 1 by n is equal to half. Okay, if 1 by n is equal to half, or let's say that n is equal to 2. Both of these indicate the same thing. Then theta is equal to kp to the power 1 by 2. Right. Now, if I have to plot a diagram for this is theta versus p at constant temperatures. Theta is equal to p to the power half, or I can write that theta is proportional to p to the power half. Or if I square both sides, it becomes theta square is proportional to p. Now, this is again of the form y square proportional to x. In the earlier case, it was y is equal to a into x square. So, we got a parabola which revolves around y-axis. Okay, so this is the very basics of graphical representations. And here we have y square proportional to x. So now you will get a parabola which is like this. And this is the actual scenario. This is how you actually get, or what you observe. Sorry, not absorb. This is what you observe. This is the real life observation that you see, the pattern that you see of Freundlich adsorption isotherm. Okay? That's it. So if there comes out to be a question for corresponding to different values of the powers, now you know how to represent them. Okay. Now another scenario is where you take the log on both sides. Let's say that you take the log on both sides. Now again, it is corresponding to the graphical representations only. Theta is equal to kp to the power 1 by n. Let's say that I take log on both left and right side of the equation. So what I get is log theta is equal to log of k. Now we know that whenever there is a product and you have to take the log, it appears as plus log p to the power 1 by n Now, log A to the power B is B log A. So, log theta is equal to log K plus 1 by n log P. Very easy. Now, let's plot a graph. Mark this graph as important. Let's say we want to plot between log theta and log P. So log theta versus log P, this is our y-axis, this is our x-axis, and the whole equation is of the form y is equal to mx plus c, right? Y is equal to mx plus c. So of course, the slope of this curve or of this line of log theta versus log P is going to be equal to 1 by n because that is associated with x. M is the slope. So slope is equal to 1 by n. Now about the intercept. The value of the intercept, C is the intercept, depends upon the value of log k, which depends upon the value of k. Okay. So now see, as we said, k is a constant. K can take various values. Let's say that the value of k is equal to 1. If k is equal to 1, we know that log k is equal to log 1 is equal to 0. That means it will pass through the intercept. So it will pass through the intercept if the value of log k comes out to be 0 or if k becomes equal to 1. This is one scenario. Now another scenario is where the value of k is greater than 1. The value of k is greater than 1. Log k will also be greater than 0. Okay. It will be greater than 0. For example, log 2 is 0.3. It is greater than 0. So any value greater than 1 will give an intercept. See, log k is the intercept. Correct? Slope is equal to 1 by n and the intercept, you can write that as well. The intercept is equal to log k. And if the value of k is greater than 1, the log k will take values greater than 0, positive values, and hence this is how the curve will be. See, this is the intercept that you will be getting. And this is positive. Correct. So this is when log k is greater than 0 and the value of k is greater than 1. Now let's take a scenario where the value of k is less than 1. So if the value of k is less than 1, you know that the logarithmic values of k being less than 1 is going to be less than 0, which means it's going to take negative values. So it will go like this. This is when log k is less than 0 and the value of k is less than 1. I hope you understand this. See, this is negative y direction. This is negative y. This is positive y. And we are talking about the y-intercept. See, it touches the negative y-axis. So this is a negative intercept. This is a positive intercept. This is 0. So all these three possibilities exist. If you plot log theta versus log p, all of them are linear. All of them are linear. Okay, whatever be the value of 1 by n, all of them are linear, but then the intercept can take different forms. In the earlier graphical representation, it was not like that. It depends on the value of n. If value of 1 by n is equal to 1, then it will be linear. Otherwise, it will take parabolic shapes or any other shapes depending upon the value of 1 by n. Okay. So why I'm stressing on it? Because we have got a question before as well. So let's try to do some questions and wind up the session. See, in Freundlich adsorption isotherm, a linear relationship is obtained in the plot of what is the question? So see, theta versus p. No, we won't get a linear graph for theta versus p in all cases. This is conditional. This is conditional. That means only if 1 by n is equal to 1, then theta versus p is going to be linear. That is the case 1 of what we have discussed. So that is not the answer. The answer is B, ln theta versus ln P, which we have already discussed, right? So theta is equal to Kp to the power 1 by n. And they have taken natural log, that's fine. Ln theta is equal to ln K plus 1 by n ln P. So this is going to be our y-axis. This is going to be our x-axis. It's so 1 by n is going to be the slope of the straight line and ln K is going to be the intercept of the straight line. Yeah. So see, this question was asked in GATE 2019. Very easy. Okay, let's try a different question. This question was asked in 2016. Pause the video, read the question, try it out on your own, and cross-check with the answer. Okay. So the question says, the adsorption isotherm, so isotherm of course means the temperatures were kept constant, of three gases A, B, C are shown where theta is the surface coverage. Okay, so extent of absorption is also known as surface coverage. So you have to write the correct order of extent of absorption, correct order of theta. Very easy. Okay. So for this, let's say I draw a straight line corresponding to a particular pressure. Any pressure I fix. So now be careful. Look what is there along the y and what is there along the x-axis. Be careful. We can see that along y-axis we have 1 by theta and along x we have 1 by p. Now let's say that I am fixing the value of pressure. So for any constant value of pressure, I will be having a constant value of 1 by P, right? So let's say that this is my constant pressure that I'm taking, any value. So I'm fixing this value. So at this value of pressure, at this value of 1 by P, the order of 1 by theta is, what is the order? 1 by theta takes the order, see, this is the highest, and then this one, and then this one, correct? And then this one. Correct. So 1 by theta at a particular value of pressure. So if pressure is constant, 1 by P will also be constant. Correct. And the value is A greater than B greater than C. But what we need is the extent of adsorption of theta, not 1 by theta. So you will take the reciprocal. So if you take the reciprocal, basic mathematics, if you take a reciprocal over here, the signs over here will reverse. It becomes A less than B less than C. Or in other words, if you want to compare, you can put arbitrary values over here. Let's say that the value of A is 1 by 2, this is 1 by 3, and this is 1 by 4. Okay, so this is 0.5, this is 0.33, and this is 0.25, you know. Okay, so I have taken just random values. Now we have to take the reciprocal, correct? This was 1 by theta. We need to get theta. So if you put it upside down, this is going to be 2 less than 3 less than 4. So C is going to be the highest, followed by B, then A. C highest, followed by B, then A. Option D is the correct answer. A question which was asked in 2016. Very easy. Okay. So it is very closely related to the problems that we did in chemical kinetics. I'll attach the playlist of the chemical kinetics in the description box if you want to refer. So yeah, that's all. So that is the end of Freundlich adsorption isotherm. Very easy. And in the next, we will be learning about another adsorption isotherm. We will also be discussing about the need for another adsorption isotherm. Okay, so see you in the next video. Bye-bye.